this webinar, it was actually going to be a series of 3 webinars that we have. This series is on HSS, and what I'm going to actually be doing now with this particular series of HSS is to explain it exactly the way I do it when I teach it in the classroom to our customers. And the way that these seminars will be built, the next three seminars will be HSS Part 1, as you already know. The next one will be HSS Part 2, and the third part will be HSS Advanced HSS. By advanced, showing you actual practice and certain situations how you can use HSS to help you out in those matters. But like I said, we want to actually make sure everyone gets a good education as far as HSS and what it can actually do. So we decided to do a webinar on this particular subject as well. I just want to make one note for everyone. The webinars will be recorded. They are recorded. I record every single one of my webinars. They are now available for everyone to view. Probably around 24 hours afterwards, it's posted on our website. As far as where on our website, very simple. If we go into our website, we have a tab called Webinars. And on the tab Webinars, we have webinar recordings. By clicking on webinar recording, you can see all the webinars I've done in the past as far as the series of SolidCAM University. And you can watch any webinar that you want on directly from our site. And I'll be posting the next one here as well. Now, before we continue our webinar, let me just remind everybody as far as questions. Everyone can ask questions. The way that's done is just by clicking raise your hand. And in the question box, write down your question. And when you finish writing down your question, just click on send. And at the end of the webinar, I'll try to answer the questions as best as possible. One note, however, about this particular webinar and the questions, since I'll be doing a series of webinars on the issue of HSS, I'd like you to also limit your questions to what I'm actually showing today. Because most likely things that I won't be showing today will be showing in the next webinar. And you'll probably have the question answered then. So try to limit the questions to what we've learned today what we will be learning today in the webinar. By the way, one more note before I actually start the webinar is that next week, the webinar, we will not be having a webinar next Wednesday. It will be held the following Wednesday. In other words, in 2 weeks from now will be the next Wednesday. We have a little technical problem for next week. So next week we won't have one. However, the following week we will, as well as the week after that, and it'll be on the issue, on the subject of HSS. Okay. Now, let's start. First of all, what exactly is HSS? Well, HSS is working on surfaces. Well, what do I mean by working on surfaces? As opposed to working on a solid body such as HSM or 3D machining, HSS has no idea about a model on the screen. All it knows is what you tell it, what surface you want to work on. So if you click on a surface, say example, this surface over here, if you want to click on that surface, that's the surface you want to work on. It doesn't see anything else. If it has a hole on the surface, it won't see it as a hole. It will see it as an area that does not have any kind of surface on it. So in those areas where you have a hole, it just won't machine because it doesn't see it as a hole. It sees it as an area not to be machined. What does it actually do? Well, we'll see that exactly in the program itself. Also, it should be noted that it also doesn't see anything on the side. It only sees the exact surface that you pick, and that's the surface it will work on. So if you have a surface on the side that may interfere with your machining, it won't see that surface. It may even gouge that surface. For that, we also have, however, a tool called gouging, which we'll also take a look at as I cover, as we go through HSS. Okay, I'm going to actually start with the simple part that I have on the screen. And even though you may not necessarily want to do this in HSS, but the idea behind me showing it to you on this particular part is to understand exactly what kind of movements are actually being done in HSS. So I decided to start on a very, very simple part. What I'd like to do when I start off this part is to first start by machining this particular surface over here. This surface as shown over here. So what I'll do is I'll start my HSS. And in HSS we have all of these options over here. Today I'll be going through the first two options over here, as well as parallel cuts, linear and constant. For this particular operation, I'm going to use what we call parallel cuts. Now, when we have parallel cuts, you have to ask yourself, parallel to what? The answer is very simple. We have several choices here, but I'd like to actually work on these two over here. Parallel first to constant Z. In other words, the cuts will be working to parallel to your Z plane that you have on your machine. The actual cuts, that means, is actually being done in X, Y all the time. Let me choose this, and we'll see exactly how this works. Next, I have to choose my geometry. Choosing a geometry here is actually very simple. You have to choose first your drive surface, the surface that you want to actually machine on. Just click on New, and click on the surface you want to machine. That's it. You'll note that I've clicked that surface, and you'll note there are holes on the surface. Those are areas where nothing will be done. In other words, it will not go through that area. It just won't machine that area. Okay. Next, we have our drive surface offset. If you don't want to actually go to the finish of that surface, but leave a little excess material on the surface itself, you can do that by giving it an offset. You can also give it a negative offset, as shown here in the diagram. It will actually go deeper than the surface and actually go further into the surface itself if necessary. Okay, these parameters over here I'll talk about in a few moments, but let me go now into Tool. In Tool, I'll select the tool. In this particular case, I'll be using a bullnose tool of 10 millimeters with a 1 millimeter radius on the corner itself. And levels, at this point, we don't really have anything to do with levels. The only thing here in levels is just your retract distance and safety distance. So we just continue to the next parameter. The next we have our toolpath parameters. What do we need here now? Toolpath parameters, the important objects. First of all, our maximum step over. How much do we want to step over or step down? In other words, from one step to the next, what's the distance we want to travel? That's done over here. Another interesting parameter that we have here is this one over here. Say you have a surface that goes all the way around, but at the end of it is a little broken between the actual beginning of the surface, and you want to connect them as to be one surface over here. This can be done by what we call surface as merge distance. So if, let's say, the distance over here is 5 millimeters away and I want to connect them, I put in here a distance of 6 millimeters. But I'm just going to leave it now the way it is because I really don't need it for this part. Just a quick explanation of what this actually does. Next, let me just go into sorting for a moment, just to show you that the cutting method could be either back and forth on the part, zigzag as shown over here, We can also do one way. In this particular case, I'm not going to use one way. One way is used specifically when you have a closed surface. In other words, the ends of the surfaces touch if we're to go around all the way around. So keep on going in one direction. We also have spiral, also not necessary for this particular case. I'll show it to you very shortly on a different part that I have. Okay, I'm going to go to zigzag. And without doing anything else, without going into the next options, which I'll go through in a few moments, let me just do a quick save and calculate. And let's see what we've got up until this point. We'll run my simulation. And as you can see, the tool is machining that entire surface. You'll also note that wherever we had the holes, it just went up over the holes and back down where it came, went back down on the other side of the hole. It did not machine the areas of the holes. It just went up to its clearance area, clearance distance, and went over and then went back down. The edges, same thing. Before it went from one slice to the next slice, it went up to its clearance surface and then moved over to the next edge over there. Now, let's see how we can manipulate it so that we can actually have it cutting straight across instead of jumping up each time. Well, for that, we'll go into our next option. Our next option excuse me, we talk about is links. Now we have approach and retract. I'll get back to that in a few moments. Let me go into link. Now, if we take a look at the link itself, you'll note our first area here called gaps along cut. Gaps are actually broken parts in the toolpath. Note we had a toolpath going across over here. It was broken by the fact that there was no surface over here. And there was a gap on the surface between this point and this point. So this tells you exactly what to do when you have a gap. Well, it said on small gaps, if the small gap was small, just continue directly to the next area, to the next surface. Now, what makes for a small gap? That's defined over here. The default value is 20% of the tool diameter. Anything less, from 20% of the tool diameter and less, it's considered a small gap and will go direct. Now in our case, it jumped up. Why was that? Because in the large gaps, which was larger than this area, it went to clearance area. So we can just go in here and click on direct as well. Let's see what happens now. I'm not finished yet, but let's see what happens up until this point. We'll run our simulation. This time, you'll see that the toolpath goes directly across to the next surface. It doesn't go up, it goes directly across. However, note at the ends. The ends, it still jumps up. Why? Because the end is not a gap inside the toolpath. Rather, it's working between slices. It finishes this slice, now it's going over to the next slice and to the next slice. So let's look at what we can do over there. Next, we have the link between slices. Again, we have the small moves direct, and we have our large moves clearance area. Now, I can go again into clearance area, into large moves, and make that direct. But you know what? I don't like that too much, and I'll show you why. If we take a look at the actual toolpath, you'll note that when it finishes at the edge, it goes directly down and then goes over. I'd rather actually go, when it gets over here, to blend itself around and come back into here instead of going into a sharp turn over here. So we can use a different option. We have here an option called blend spline. Blend spline, as you note in the diagram over here, allows you to actually blend the two tool paths, those the two slices, together. And it does it in a smooth fashion. Let's take a look exactly what happens over here. And I'll turn it this way so you can see it a little better. Now you can see that the toolpath curves its way around over here. Take a look at the entire toolpath, and you can see that everything is working directly over these edges over here. Now, before I go to my next option I want to show you, let's take a look at the lead in and lead out. Note when it comes onto the part itself, at this point it's going straight in onto the part. I'd actually rather have it go in using an arc. The same thing over here, I'd like to actually exit with an arc as well. So let's go back into the program, and now we'll look at approach and retracts, where I said I'd get back to, and as promised, I am going back to it right now. We have from clearance area, I'm going to leave that, that's fine with me, and last exit to the clearance area. But we have here, don't use lead in. And for the last exit, we have don't use lead out. Well, I want to use my lead in and lead out. So I'll just click over here and say, okay, use lead in and use lead out. Now, I'll do save and calculate and run a simulation, and you'll note that we have a lead out. Now, where did this lead out actually come from? Let me go back into the program. We have on our next line after link, default lead in and lead out. This exactly controls our lead ins and lead out, the default for our lead in and lead out. Our default in this particular case is tangent arc, as shown over here, going tangent, an arc that's a horizontal tangent. If we want, we have another option I could have done, was also vertical tangent, coming in from the top. But I want to actually have it coming in from the side, so I'll do a regular tangential arc. These parameters here I'll go through in a few moments. Note my lead out, I can have it same as lead in, or have it different. Again, I'll just leave it exactly the way it is. And as you can see from your simulation, we have our lead in over here, and at the other edge, we have a lead out. Now, one more object I'd like to show you over here as well is if we take again a look at the toolpath, you can see that it's coming exactly to the edge when it comes over here. What I'd like to do actually have it extend a little further out. So if I go back to geometry, and I'm going to go back to these parameters over here, and I'm going to use the first parameter, the first one being extend trim. If I want, I can extend or trim the ends of the surface itself. In this particular case, I can either do it by tool diameter or value. I'm just going to make it at 5 millimeters, and the same thing at the end at a value of 5 millimeters. Do OK, calculate, and note now that the toolpath goes further out past the part itself. Okay, let me cancel that. Click on OK, and that will be canceled. Now, one other thing I'd like to show you is that right now it's working on the entire surface, but if I want, I can actually limit it to work within a specific boundary. Let's choose the option over here of 2D boundary. If I choose the option of 2D boundary, I can say, all right, let's use it. Let's define it. And if I'll go into my top view, I'm going to choose this little sketch I have here on top as my area. Note it's on top of the part, it's not even touching the part. But that's the boundary I want to work in only. Accept that. Save and calculate and simulate. You'll note that it only works in that particular area, nowhere else. Okay, next, next I'd like to go and create another operation on the same part, and I would like to show you what linear does. So I'll create another operation here, and I'll use the option of parallel cuts linear. This time I'm going to machine this surface over here. Now note, this surface, obviously we all know that normally I would do something like this using a face mill, but I just want to show you some of the effects of what happens when I machine this. Now note, on this particular surface we have several types of gaps. We have a gap of holes over here, and we also have a gap of a large surface. Okay? So let's see exactly what happens when I actually do the operation here. Tools. Again, I'll use the exact same end mill. Levels, Toolpath parameters, quick save and calculate and simulate. Okay? Note what happens. By the way, if anyone wants to know, I'm working right now in SolidCAM 2013. However, these options, what I'm showing you here, is available also in 2012 and 2011 as well. So there's no difference as far as the versions go. Okay, now, note what happens. We have our gaps. Again, it jumps up over the gaps. Same thing over here. It jumps up over this large gap over here, these gaps over here as well. Now, I can do what I did before, but it's not really going to help me, because what's actually going to happen is like this. If I were to change it exactly the way I did before, go into my links and change this to direct, it'll go directly over on all of the areas. But note, the feed that it will use when it goes from this area to this area over here will be the regular cutting feed. Same thing over here. And for such a large area to go slowly over the cutting area, wherein you're not cutting, doesn't make sense to me. Okay? Obviously, if you actually really did have material over there, then I would say, okay, leave it and do it this way. But let's say we don't, everything was cleaned out over here. So what I'd like to do is to move rapid. Now, when it goes up to my clearance area and goes across, it moves rapid. So what can I do as far as having this area go direct, but this area pick itself up and then go rapid across to the other side? Well, we can simply do the following. We have our gaps along, cut. I'm going to change this back, the large gaps, I'm going to change this back to clearance area. What I'm going to do is actually change my small gap size. I'm going to make my small gap size much bigger, let's say 50 millimeters. So anything that's less than 50 millimeters, it'll be treated as a small gap and work direct. Anything larger than 50 millimeters, that's considered a large gap already, and that'll go up to my clearance area. Let's take a look exactly what's going to happen now. Note that it's going directly to the other side over here. Whereas this area over here, it actually jumps up, goes to the other side, and then comes back down, and then finishes. Now, first of all, what I'd like to do, let's see what happens if I add in my approach and retract, use lead in and use lead out. Run my simulation. And everything is exactly the way I expected it to be, but note at the beginning, at the end, we have our arc in and our arc out. Now, let me look at this area over here. You'll see that this area over here, when it gets to the edge, it goes directly up and then further up. I actually like it to go out of this area using an arc in what we call a vertical arc from these edges over here. And the same thing when it approaches, to do the same thing. So let's see what we can do about that. We can go into our links and we can deal with it over here. When we have our large gaps, I can say, you know what, our large gaps, I want you to use a lead in and lead out. Now, if I were to leave it at the default lead in, lead out, that won't be good. Why? Note what happens. It works exactly the way this worked. In other words, it's curving its way out to the side and not going up like I wanted it to. So I don't want to use the default in this particular case. So when I use this option over here in large gaps, we have the option of going into the settings for the lead in and lead out. And right now it says here, use default lead in and lead out. If I were to click on this, get rid of that, I can change that for this particular operation in the gaps area where we have large gaps. I want you to do a vertical tangent coming in from the top, same as lead in. Okay, let's see what happens now. Okay, what happens now is very simple. It does its arc out, but this particular arc is relatively large. Okay, and what I wanted to do is I actually wanted to go down, not to go past this area over here, but to go up just a little bit and then go up to the clearance area to go across. So what I can do for that is very simple. Let's go back into this area over here, and when it comes to our vertical tangent arc, I can tell it the following. Note the sweep angle that it's using right now is 90 degrees, and the arc size is 200% of the tool itself. So if the tool itself is 10 millimeters, the arc is 20 millimeters. So what I can do is as follows. I can either make this less, or I can even do something else. I can say my arc sweep, let's put that at 10 millimeters. And I'll click on OK. Let's see what happens now. Note, at this point, it's going up already. Now, again, we have the issue of extending it. Maybe I don't want to go exactly at this point. Let's see how we can do extending. Again, if I go back into geometry, click on extend trim. I can use the extension as well, going in as for going out. Extend it, let's say, by 5 millimeters so we can actually see it physically. Now, if I do just what I did right now, nothing will actually happen inside those areas over there. It'll look exactly the same what it did before, going exactly at the edge. What I have to do is when I use this option of extend trim, there's one more little box I should click on. That extend trim gaps as well. Notice the gaps also, I want you to extend those. Let's do OK now. Run my simulation. And this time you see it's actually going out 5 millimeters before starting the arc. Going up, and at the other side, going back down again 5 millimeters before. Doing the arc, finishing the arc 5 millimeters before, giving extension to that surface. Of course, at the end, we have the same extensions as well. Okay, I'd like to load now another part and start talking about our next option in HSS. I'll close the part, open up a next part, okay. Now, what I'd like to do in this part is to machine these surfaces around over here. Now, what we used before of parallel cuts, constant Z, won't help me over here. Even the linear won't help me over here as well, because it's going into curved areas. It's going to be just going back and forth too many times. This is not really the right way to work on this. The way I'd like to work on this is very simple. I'd like to work on these surfaces. These will be my drive surfaces around here. And I want to tell it to go parallel to this edge around over here. So I'll start my HSS operation. And I'm going to use the option called parallel to curves. Now, I did some homework over here to make this go a little quicker. So I already have my my surface that I picked over here. Have picked all those surfaces over there. And if I go to my edge curve, I have this edge that I wanted to work parallel to that edge over there. The tool that I'll be using will be a 6mm ball nose. Let's go into our Toolpath parameters. And let's go into sorting. Now, in this particular case, since we're going around the whole time, I'm not going to work zigzag. I can work one way. But you know what? Better yet, let's work spiral. By working spiral, the toolpath is continuous. When the toolpath is continuous, in other words, it's always cutting, not having to go over from one slice to the next. Let's see what happens at this point, up until this point. Okay. Note what happens. It works its way, and I'll slow this down just a bit. Okay? It's working around in a spiral way, parallel to this edge. But you know what? We have a little bit of a problem over here. What's the problem? The problem is very simple. We have the tool, and it's working on the surface, and it's working all the way to the edge of the surface. In this particular case, when it works all the way to the edge of the surface, it's going to actually touch that wall, because it has no idea that there's a wall there. All it knows is that it has to work on this surface. So what we have to do is actually tell it that, listen, we got this surface over here. I don't want you to touch those surfaces. How do we do that? That is done by gouge check. When we work with gouge check, what we're actually telling it to do is to check on certain surfaces, make sure you do not touch them. How do we do that? First of all, let's enable it. And I want to work on the check surfaces. In other words, which surfaces do I not want to work on? Well, let's define it. I'm going to click on New, and we're going to start choosing our surfaces. Let's go first surface, second surface, third one, fourth one, and that can continue going around on the part. And this is exactly what you have to do. You have to choose each one of these surfaces over here as shown. choosing that one, that one, that one, and that one, as well as that one, and that one, this one here as well, going all around, this one, this one, this one, this one. True, it's a lot of work, but you got to do that. You have to choose the surfaces you don't want to touch. We'll choose this one, and 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 we're almost done. There's a reason why I'm doing this, because I want to show you a little workaround that we can do in a part like this, not having to pick all those surfaces. Okay, as you can see, I've picked all the surfaces. Everything is fine. Now, I can even say how far away to stay from those surfaces. I can leave it at 0, but I just want to show you how this works. I'm going to move it, keep it away by 1 millimeter from that surface itself. Now the question is, when the tool sees that surface, what do you want it to do? Do you want it to stop dead in the tracks? Do you want it to go up? In this particular case, I want to use the option of leaving out gouging points. By leaving out gouging points is that the moment it sees a point that will gouge the part, it won't take it into consideration when it calculates the toolpath. In other words, it won't be part of the toolpath. Okay? Let's take a look exactly what happens. Oh, one more note. Note we have over here the area of what should be doing the gouge check. We have the tool tip. We can also have the tool shaft. We can even have the arbor of the tool, and we can even have the holder of the tool to make sure it doesn't hit that surface over there. I'm just going to leave it over here. You know what? I'll even get rid of tool shaft and have just the tool tip. Let's do save and calculate and simulate. I'll run my simulation. And you'll note that this time, the tool does not hit any of those areas over there. I can even use solid verify. You can see this even sometimes a little better that way. You see the tool is going around. You speed it up a little. And what you see over here is that it did not touch any part of that wall. Okay, now I said there's a little trick I can do instead of picking all those surfaces over there. Very simple. Let me go back into my gouge check. Okay, and I'm going to choose a different surface. What I'm going to do is I'm going to choose this surface over here. And that's enough for me in this case. Why? Because when the tool comes over here, it touches the surface as well. So if I say gouge control on that surface, it'll do the trick. However, one more thing should be taken into account. Not just the tool tip, but the tool shaft. If I were to leave it on tool tip, that won't be enough in this particular case. The reason being is that the tool tip on this particular tool is very small. It's not high at all. So the tool tip may not get into this wall, but the shaft, as you see over here, is touching the wall. As you can see over here, the shaft itself is touching the wall. So that's not going to be good. The tip may not be getting to the wall, but the shaft is. And that's not good. And we have a gouge over there. So what we have to do in this case is just add a little thing over here called tool shaft. By the way, the default of gouge check is with these two marked off over here. Let's run my simulation again. This time let it run till the very end. And you'll see this time, since the shaft can't touch this surface, it won't go past that area as well. So in this particular case, always pay attention to if you can use a different surface. Sometimes it can make it a lot easier for you to choose your surfaces that you don't have to work on. Okay, what I'd like to do right now is start taking questions on what we've learned up until this point. Our next webinar, I said, will be continuing in HSS. Okay, I'll just give everyone a minute. I have some questions here already. I'll just give everyone another minute just to ask questions. Okay, the first question I see over here is, how can I control the start at the end and the finish of my surface in up and down? That I remember, that if I understand correctly, you're talking about the lead in and lead out, and you saw exactly how I worked with the lead in and lead out. I can also work, let me just bring back the part itself, or I can actually do it over here as well. If I were to go into the operation over here, we can have here Toolpath, the links, use lead in, use lead out if I want. And in this particular case, I can use my lead in vertical as well. Okay, and the lead out, I can do the same thing. Also use vertical. Let's see what happens over here. And I'll show it using the in HostCAD so you can see the actual toolpath itself. I'll stop it now. Note that it came in from on top instead of coming in from the side. Over here, I could have come in from the side. It would have been nice as well, but it can do that. And my exit, by the way. Now, note, in this particular case, the exit went straight up for a simple reason, because it has a Gouge check over here. And by going straight up, it would have hit the wall. So it just went straight up. Okay? So in this particular case, I could have actually done my lead out. I would have used tangential arc. By using tangential arc, it actually worked tangent off the thing. It's very hard to see it over here, but it actually curved itself out. Now that we mentioned it over here, and I'm going over here, note that it's actually very close to the surface itself. What I can also do is, when I lead myself out, is I can say, you know what? Let's lead out. We have a tangent lead out, arc sweep. Everything is fine, but I can also say, you know what? Pick it up, say 2 millimeters as you're doing that lead out. You know what, let me make it 5 millimeters so you can actually see it a lot better. Run my simulation. Note, now when it curves its way out, it also picks itself off the surface as it's curving out. Okay? By the way, again, this webinar is being recorded, and it will be on our site sometime tomorrow afternoon as well. Okay, next question. I've already mentioned it. I'm working in SolidWorks version 2013, as well as SolidCAM 2013, but as far as the options that I've chosen over here, they're available in SolidCAM 2012 as well. Okay, next question. when I use extend trims, we extend the surfaces in 2 directions, but I need to extend the another 2 directions. Okay, I understand what you're talking about. Let me go back into the operation itself. And I'll open up that previous part. Okay, if I were to go into the first operation, let me go back into here, actually make a change. Geometry, let's get rid of that 2.5D boundary. You'd like to extend it not only in this direction over here, but you'd also like to extend it in the this direction over here. Well, the only way to do that is by just taking the surface in SolidWorks itself and extending it in that direction. This option only goes at the ends that it's traveling on. In other words, if it's traveling in this direction towards here, it'll extend in that direction, not over the edges. Okay? If you want to, in this particular case, just go into SolidWorks, extend, create a surface, extending it, and then work on that surface instead. Okay. I'd like to first of all thank everyone for joining me on the webinar. Again, the next webinar will be in 2 weeks. I will be continuing on HSS. And my idea is that I get everyone to know HSS as best as possible. And in 3 weeks, we'll be having our lessons on advanced HSS, showing practical uses of HSS and how to use them in particular cases. All right, everyone, take care. Have a great weekend.